This is an audio lesson on the hydrated crystals review. Let me read for us the paragraph. It says, frequently, hydrated ions remain in crystalline salts that are obtained by water of evaporation from aqueous solutions. Some common examples include iron 3 chloride, hexahydrate, copper 2 sulfate, pentahydrate. Water molecules occur in positions in the crystal lattice that are not specifically associated with either the cation, that's positive, or the anion, which is negative. Barium chloride dihydrate, I've noticed 2 typos already, I apologize, is another example of this. Compounds that contain a salt and water combined in definite proportions are called hydrates. Through the process of heating, hydrated crystals release their water and form anhydrous crystals. This process is reversible. Leaving an anhydrous crystal out in the air will allow it to grab moisture and thus rehydrate. So a couple of things I'm noticing about the formulas of hydrated crystals. We see an ionic compound, a positive hooked to a negative based on charge, and then a little dot attaching water molecules to it. The dot does not need to multiply, it simply means attach to it as part of its structure. Now, how many molecules of water that attach to the crystal end up in the name of the hydrated crystal? And again, using the same prefixes from molecular compounds, we hear mono, di, tri, tetra, and so forth. So let's begin a little bit of review, going down and looking at our first question. It reads, what is the mass percentage of copper 2 sulfate pentahydrate? Showing all work. Well, the first thing we should do is simply begin by writing out the chemical formula for the compound. Mass percentage simply means part over whole. We want to know how much does the weight of the water contribute to the weight of the whole compound. Now, again, typing won't make these subscripts and so forth very easy, but I'll do my best. CuSO4 is the compound copper 2 sulfate. Copper's Roman numeral +2 is balanced by the -2 from the polyatomic ion sulfate. Attached to it is a dot. Pentahydrate is 5 water molecules, 5H2O. We want to know how much 5 waters over the weight of the whole compound to get a mass percentage. So we'll need to begin by adding up some formula weights. I'm going to grab my calculator and begin by adding some formula weights. Let's go into the periodic table, and what we'll end up seeing are the weights of the compound, or weights of the elements that we'll need to add. Knowing that copper with a molar mass of 63.5 added to the weight of 1 sulfur, 32, plus the weight of 4 oxygens, 16 times 4, 63.5 plus 32 plus 16 times 4 gives me a molar mass of 159.5 just from the copper sulfate crystals. But remember, we also are adding water, and we need to add 5 water molecules to find the total weight of the compound. As I wait for my hydrated crystals to come back up, we'll begin by adding 5 H2Os. So the answer 5 times 18 plus the original 159.5, and I get a total weight of 249.5. Now let me remind us what I did there. Copper sulfate was 159.5 plus 5 times 18 on the water, and that gave me the total weight of 249.5. and that comes out in total grams. Now to find the weight of the water, we're simply going to take 5 times 18, which ends up to be 90, and we'll divide that by the total mass, 249.5, and I am including units, part over whole, and then we need to express that as a percent, and we'll come up with the mass percentage of water. So 90 divided by 249.5 times 100, 36.07% by mass water. 36.07% mass by water. Now, as we take a look at our second example, done the same way, what is the mass percentage of barium and barium chloride dihydrate? So again, we need to consider writing the correct chemical formula first. And when we see that, I'm seeing the prefix di representing 2 water molecules attached to the salt called barium chloride. Writing the correct chemical formula. Wait, my page is scrolling up. Here we go. BaCl2, barium with a +2, chloride is a -1. When we crisscross, we get BaCl2. The little dot that is between them, and again, I'm just using the period on the keyboard, but that is a dot attaching 2 water molecules. Notice this time we're being asked for barium and barium chloride. I will talk through the strategy and allow you to hit. Let's find 1 barium plus 2 chlorines plus 2 water molecules, and that will be the weight of the whole compound. Then take the weight of 1 barium over the weight of the entire mass and express that as a percent. The problem-solving strategy is identical to number 1, but instead of targeting water, we are targeting barium. And again, I won't work that out. I'll allow you to follow the strategy, mass percentage by barium. Let me talk you through number 3 as well. Upon analysis, a hydrated crystal was determined to be 14.29% sodium, 9.94% sulfur, and 19.88% oxygen. 55.9% water by mass is included in this weight. Determine the empirical formula for this hydrated crystal, and we will name it. What we'll need to do is go to work finding the empirical formula of the salt and of the water. Notice here what we've got is 14.29 plus 9.94, 19.88. Those are all percentages giving us a total of 100%. The strategy for determining empirical formulas is to take the mass percentage and divide it by the formula weight to turn it into a mole. So for instance, to begin with for sodium, let's bring my cursor down to the right spot. Let me get it over there. Everything is delayed when you're recording. All right, to begin with then, we'll have the work shown for sodium, Na. We'll take the 14.29% and just turn that directly into a gram. Out of 100 grams, 14.29 come from sodium. We'll divide that by the atomic weight of sodium. Again, checking your periodic table, it has a formula weight of 23, and we'll find a unit known as moles. Let me hit that for us. 14.29 divided by 23 looks like 0.6213. And again, my strategy is to carry all the decimals possible to eliminate rounding errors, and that unit is mole of sodium. Next for sulfur. Sulfur has 9.94 0.94 grams divided by the atomic weight of 32, giving us, I'm finding 0.3106. 0.3106 mole sulfur. 19.88 grams out of 100 grams are coming from oxygen. And oxygen's atomic weight, never use molar mass of 32 in these types of problems. It's always the atomic mass of 16. And I should label that as oxygen. Just so it doesn't look like a 0. And now I will hit then also the number of moles. And what I find, 19.88 divided by 16, 1.2425. And that becomes mole of oxygen. I'm seeing a 0.6213, 0.3106, 1.245. There's one more that we need to calculate, and that is for the water. Water was 55.9% by mass, so that's 55.90 grams out of 100 grams coming from the water. Divide by the molar mass of water, 2 H's and an O added together gives us the formula weight of 18, and we'll calculate for the number of moles of water. 55.9 divide by 18, and that's 3.1055. 3.1055 moles of water. Now, the strategy for turning these into whole numbers to work it into a formula. As we skim through the entire list, we want to find the smallest number and divide them all by the smallest number. When I look over the list, it looks to be coming from sulfur. So what we'll do then is go back into our list and divide them all by 0.3106. 0.62313 divided by 0.3106 gives me a value of 2.0003. That's a number of 2. Of course, any number divided by itself will give us a 1, but we'll show the work. 0.3106 equal 1. And going down to the oxygen. Boy, this is an art, getting your cursor to where you want it to go. 1.2425 divided by 0.3106 equal 1.2425 divided by that smallest number, 0.3106. 4.0003, that's a number of 4. And finally, dividing through this 3.1055 moles of water by the smallest number, 3106 equal 3.1055 divided by 0.3106 is 9.998, which is a whole number of 10. To determine the empirical formula, we take the subscripts for the sodium, sulfur, and oxygen to create the formula for our ionic salt, Na2SO4. Na2SO4 is sodium sulfate. To handle the water, remember the hydrated crystal has water attached to it. To show the attachment of water, we use the dot. So remember, the dot is kind of between the two formulas, acting as a little dot attaching to it. The number of moles of water attached was 10 H2O. Now, you, of course, are using the appropriate subscripts and so forth, but it would be too difficult to type in that right now. To name this, sodium sulfate handles the ionic compound. The prefix for 10 is deca, so we'll type in as one word, decahydrate. Oops. There we go. Na2SO4, little dot for attachment, 10 waters, sodium sulfate, decahydrate.